Hello, gentle readers, fellow earthlings. Welcome to this week's episode of Logos 2000 21st Century Foundations, April 27th, 2025. The idea today is to look at some books in logic and then some more from the stack of the differential equations books. And just to establish kind of familiarity with some of these sources, and then to describe a little bit more of the gamut, of the range of books in differential equations with regards to the developments over time, and then the industry of methods in differential equations. And here's with regards to the integral the integral equations, and to be looking for some connections in these books from the differential equations to the integral equations, particularly about the kind of profound and multi-flavored Duhamel's principle. That the Duhamel's principle kind of seems to arrive at kind of like a wavelet embedding core of the differential and integral equations together, and helping to affect the reflect it for something that's like between the linear as above a straight line and underneath the exponential, about that, because the differential equation and e being its own antiderivative, an integral, and then about straight lines and the identity dimension original analysis here. And then with regards to zero, the zero function, then also about vertical lines, a little bit more about what it makes to stand up a vertical line, in terms of what kind of counting arguments might go into that, where the idea of a new idea is that there's a way to make kind of pyramidal numbers underneath the fulcrum of a lever of sorts at the origin, say, as with regards to, besides curvature and that being just kind of a measure of the path, and also kind of the bulk and aggregate concerns, which would make like this ridge, basically, that would be able to hold up this line, and then how to make it so that the 90-degree turn going from the zero function to a vertical line can kind of result is more well defined, or at least defined another way, and so helping to excuse me, so helping to give another analytical account of this, when it's otherwise among the asymptotes and the intractable, thusly. And for example, in classical functions, there are no vertical lines at all. So what do we call that? It's like, well, if it's a function, it's a relation between numbers, or it's a geometrical object that emits the definitions of function. And then when differential geometry says, oh, we're not going to have a zero function either anymore, but it really solves a lot of stuff just inside a quadrant a lot easier. So with regards to omitting the envelope, say, that in this manner, one hopes we can just kind of introduce the cursory aspects of this sort of concept, then, as with regards to what role it may have to be able to provide for special functions that actually would be able to sit and hold that up. This is kind of one of the new ideas going along with the original analysis, the identity dimension, the stop derivative, the walk integral, and related terms, the Hatz analysis, Zeno's swath, and otherwise with regards to modern accounts, particularly for motion, and for all sorts of dynamical modeling, to have that the integral and differential analysis are always together, and that the great strengths of having one by itself and just kind of running out its bounds and the completions of those then isn't blind to what's its kind of necessary complement of this meeting in the middle of nowhere type things, as with regards to more replete the completions. So let's take a look at some of these books in logic, say. What I've been reading for several months now, day by day, or for a few moments at a time, is this Quine's Word and Object. So Willem van Ormond Quine is a 20th century logician. He studies logic and he makes logic. And so he's pretty famous in the before the Berkeley School and Tarski, say, and the Berkeley School. And then as with regards to like Dana Scott and that, has that Quine is at once pretty thorough and on the limited kind of half-inductive account side, as it's put here in these talks. So he knows how Russell's formalisms are made to so arrive, and then he points out why and how they would be lacking or something. Or here that in word an object, he's looking to relate the study of the attachment of language to logical objects. So there's Quine and then there's Strawson, P.F. Strawson, and they both have some improvements to otherwise stuff like Nelson Goodman's inductive riddle or these kinds of approaches. That when reading this, I pretty much always will start reading it, and he'll be making some sort of defense of, well, this is how we do it. It's not quite general, but we can give that up because convince me I'm wrong. And so this is kind of what I've been getting from Quine a lot. Opacity and indefinite terms. Since indefinite singular terms do not designate objects, we have had only definite singular terms in mind in our consideration of referential position. The terms will be replaced by others of like designation and testing for substitutive identity are definite singular terms. Still, we are testing our positions, and indefinite singular terms can be put into them. Let us see with what effect. So one thing about this is trying to figure out the definite and the predicative of language. And one kind of weakness or perhaps feature of Quine's approach is it doesn't really admit that any reading has two readings, at least. And when they're closest in form and they don't seem to differ at all, then you can say it kind of has one. But any different emphasis on the terms can contribute significant weight to the meaning of the things, or the meaning of the things, or the meaning of the things, or the meaning of the things. So this is one of these ideas then that is not lacking from the language necessarily, but maybe lacking in the notation or in the description. And so he gets into notions like Cicero, Tully, and Catiline, and those being just kind of examples of variations in emphasis, and then about terms, predicates, and relations, with those being in regards to propositions. Here, everything's kind of considered relations. And then the object-verb distinction or verb-object distinction, where various languages have those variously. And then, so what some things is what does, and others what is, and all these notions of copulas and the connectives. English, the language. But then for the mathematical symbolic logic, the language, it's in terms and predicates and relations, and constants and variables underneath those. And so a lot of times Quine will get to writing, it's a lot like after Frege, it's a lot like after... or I'd say Frege mostly, but I've definitely heard most people say Frege, and that's the way it's said. Gottlob Frege, that the terms are like these, but Quine is dealing with the tools. He's very familiar with the whole tool set of word and object in this logic sense, in this language and linguistic sense. But then he doesn't really. He'll often find the cases where it's ambiguous, or the ambiguities, or the impredicativities. And then when he does so, that he doesn't really allow it to, they kind of come to its greater form, is mostly he gives justifications why to ignore that. And so I don't consider him a hypocritical flake like Russell, because Russell will kind of be like, well, now I've just defined away this, A is element of A, and I brought in this A not element of A, and so I made Russell's paradox, and so after I make 2 or 3 layers of definitions, I'll give truth as just having the same members in a set theory, and then instead of having that being like the equals is an operation, in computer science, equals is separated into 2 things. An evaluation, are 2 things equal, and an assignment, this is now equal to that. That these are some kinds of things that Russell will just kind of bulldoze right over and expect that to be then it's a self-contained inductive account. And it's about the principle of contradiction versus this inverse contradiction that's discussed here a lot. The Quine is he'll bring up these ideas in kind of a tantalizing tease of, well, these would be out of line or out of the field. And he doesn't actually at least close the door on that way and say this like, so we will just, so it's not so. And he doesn't exactly ignore these things altogether, but he does kind of make for that. He will just kind of leave those out, and then that's fair. But when he claims the praises of these other things, it's like, well, we're not going to need that. We're going to always be like so, because earlier in the development it's been said that it's always going to be like so, even though we've turned over and tossed over a bunch of these different things that would maybe contravene that. We're going to have to assume that everything's perfect in the middle. And so that's a way to make a generous reading of Quine instead of just being inconstant, and as with regards to all the actualities of the singular and the universals in language for logic. So he talks about failures of substitutivity of identity, moreover, were in Frege's view unallowable. So he nominally rectified them by decreeing that when a sentence or term occurs within a construction or propositional attitude or like, it ceases to name a truth, value, class, or individual, and comes to name a proposition, attribute, or individual concept. So, lifting the language of the dialogue and adding more to the word soup, as it were, unfortunately makes for the unaware observer, it looks more like word salad. And so then trying to figure out how to have that into the things is, for here that is relations is what's in the language, and the relations are the logical objects, and thusly ternary or expressions are merely as relations. They have ranges. Besides defining a template or pattern, fill in the blanks, then there's also piece by piece constructed, beads on a string, connect the dots. So between connect the dots and fill in the blanks, or one is kind of like this geometrical aspect of all the objects in the world in the language, and the other one is like this view of all the perspectives and lenses, which allows that to kind of then have both those kind of attached approaches. That inevitably a great development has been kind of like one of those. And it's like, well, this can only result fundamentally of this kind of relation. But when it fundamentally arrives at it's got to be this balance in the very core of the things, then of course these are the ideas here to try and promulgate that to make a more replete foundation, since otherwise it's just kind of lacking. So Quine is a great logician, and he addresses and points out these issues, and he's at least conscious and honest about what would be his foibles. Then he kind of offhandedly puts them aside. It's considered that at least is still kind of left there to be discovered and picked up. So one would imagine that if one wanted to make any kind of approach or attack on logic, this kind of 20th century way, fin de siècle way, then you could pick up almost any page in Frege or in Quine here and find something to start breaking it down, whether it's in terms of the variables and the terms, or like the spaces of the words. This connect the dots versus fill in the blank, which are so disparately different, yet it's only ever kind of the one or the other of those, and so it is both. So he talks about Giorgione equals Barbarelli, the commissioner, to resist substitutivity. And there's temporality and modality. We consider that our relevance logic that is true always has temporality and modality. There's one of them, and then anything else is just kind of its own consideration in relation to that, and all the other ones as well. Ernest is hunting lions, mutatus mutandis, with regards to language, word, and object. Regimentation. I've been reading this piece by piece, and so as it is kind of so, it's structured as a series of lectures that he gave back in the 1940s or 50s, I guess it was. And in 1954, and 1953 and 54, that this book was printed in 1959. And as to whether, Quine basically he wrote his lectures, essays, and then just read them. I'm not too sure about how he presented these. But if you're looking, perhaps you can find some recordings of Quine and see if has some recordings of word and object. Lesniewski. Lesniewski is in the time of Tarski's life when he was in Poland, in Krakow, or where he was as a young man, as an undergraduate. And Lesniewski was there, and so he's a big Polish logician, and he along with somebody like Kleene and Lukasiewicz, they had a lot going on with at least introducing this third idea, like, well, there's true or false, it's tertium non datur. Well, there's it's undefined. Okay. So that's Kleene, or that's Lukasiewicz then, but Kleene then also had matching and regular expressions, yet also with regards to those being higher order constructs, and it's part of this difference between this, what I'm just calling since a few minutes ago, connect the dots and fill in the blanks of the analysis of language and logic with regards to language. And that's for the logic, that's that, geometry is motion, but it's always perspective and projection. And then with regards to a recount, it's always through the lens, through the language of these things. So this is a great little book. And he gets talking about C.I. Lewis, I believe it was. It is doubtful that Lewis would ever have started this of Whitehead and Russell, who followed Frege in defending Philo and Megara's version of if P then Q as not P and not Q, which we would just say that is Augustus de Morgan's, along with all the rest of them, had not made the mistake of calling the Philonian construction material implication instead of the material conditional. Oh, this is even worse, because here he's getting into, like when we read from Suzanne Langer's about the material implication, because that's the quasi-modal aspects, and he gets in all the paradoxes of material implication. It's not material, it's not implication. It's the wrong thing to say. It's after reading from Plotinus, so he says it's got a Philonian construction, and I'll look but Megara was a ways back in like the time of Zeno and that. But that's the quasi-modal. And so here, with regards to the earlier comment, that it's the relevant temporal modality of the logic that keeps things true, that this is not so. Quine then is making a quick defense of why it should be called something else, because it causes a lot of confusion, like quasi-modal inference or something like that. Material implication instead of the material conditional. Lewis protested that a material implication so defined would have to be not merely true but analytic in order to qualify as implication properly so called. Such was his account of strict implication, or here it's called direct implication. Implies and is analytic are best viewed as general terms to be predicated of sentences by predicative attachment to names, e.g. quotations of sentences. So anything can be quoted and nested deep, and grouped and nested deep. And so when you look at any particular group of words that makes a sentence, they're connected in all the different ways and then deconstructed and reconstructed at the same time just to connect the dots, each of the blanks that can be filled in. And so the space, there's this third kind of space of those, connect the dots, fill in the blanks, and do all the combinations, I suppose one might say. So that I would relate to three models of continuous domains: the line reals, the field reals, and the signal reals. Where that's here at least been given a quite usual amount of standard formalism to make so that those are acceptable objects in mathematics. Whitehead and Russell, careless of the distinction between use and mention of expressions, wrote P implies Q in the material sense interchangeably with P then Q in the material sense. Lewis followed suit, thus writing P strictly implies Q and explaining it as necessarily not P and not Q. Hence his development of a modal logic necessarily as an operator in sentences. So yeah, this Lewis is, and there's quite a few different Lewises in logic. It would be better. But emerges when, as in Carnap's writing, the distinction between use and mention is carefully maintained. Indeed, it emerges as the very distinction between modal logic and ordinary talk of analyticity. It's not so ordinary, that talk of analyticity, because it doesn't, you wouldn't call it a truth value, you'd call it a contingency. It's contingent and contingent and contingent again, instead of relating to direct implication, which is logical, the causality of logic, the deciding power of logic, and being just kind of hazardous in a minefield of sorts, and separated from a simple ledger of results to being a precarious pick and choose. And then also the temporal modal logic has this kind of weakness that in rules, systems, and engines based on that, you can just toss in a rule anytime going along, and then everything else is broken after that. Broken by that. That last wins. And so instead of C rule 1, which is not wrong. It is the case for induction. It's the empirical case for induction. It's not necessarily complete. It can't complete itself, and it can't contradict itself. Here it's that somebody can come along and say that, oh, material implication in that being analyticity is that being not analyticity. And so anybody can throw along a fact stipulated anywhere along the line, and having broken the induction, carrying it all the way down the claim. The relevance modal temporal logic, one modality, a temporality. And relevance, meaning the terms it is what it is. That's considered of quite thorough analyticity and quite sufficient. So and that it's necessarily not to have the material implication. So it's appreciated that at least Quine takes sort of neutral stance on material implication. Proponents of modal logic need not all be concerned with necessity in this extreme sense. So now I just maybe use that word in this extreme sense, and I subconsciously had already read this line, or I've read this before. At the same time, it's also kind of so. So I could say that Quine is observing this same statement. The necessity concern might be construed rather as some sort of physical necessity without modifying the form of the system, or might be construed as conditional necessity relative to some unspecified set of premises as parameter. He says, see further Quine's 3 grades of modal involvement. So that's something to look at. And then this is like in the time of Reichenbach and Carnap. And so Reichenbach is just kind of a linear flake. It's like, I've discovered statistics and some theories of large numbers, and I know that there's at least 2, but I have no idea else about them. So I'm just going to use the strength that I have to make for these ones very, very strong, and say that now statistics is a great rule of things. And it's like, well, statistics will lie if you let them. And then Hintike talks about Church's review of my notes on existence and necessity. So that's like Church Rosser and Church Rice and Church Kleene. Modal logic, as systematized by Barkan and by Fitch, allows unrestricted quantification into modal contexts. How to interpret such a theory without making the disastrous assumptions by no means clear. So here we talk about the extraordinary, and that it's under then these superclassical accounts of what can be deductively grounded inductive completions, like Zeno's arguments, the yin-yang ad infinitum, Zeno's graduation course, Fourier analysis, other matters of completions in the infinitary, the line integral, and analysis writ large, infinite expressions and their limits and convergence and emergence. These are the kinds of things that have then examples that are like, well, this is kind of what mathematics gives. It's like mathematics gives a circle. And so this is an example of like a higher order form that's got isoparametric theorem satisfied in all dimensions. So you can use that, not so much as like, well, I can just draw a large wavy line around anything and say that's big enough. And it's like, well, yeah, but that doesn't exactly fit anything. So these are the ideas that for logic, similarly, it's called mathematical logic. And so you got the space of words, connect the dots. You got fill in the blank and all the relations, however they're so satisfied and matched and connected. And then there's this other space of words, which is like, and what could all those be? And in every possible order in this kind of thing. That a temporal relevance logic makes it so then all these stipulations get put in a jar or a hat, say, and thoroughly and randomly mixed, poured out, and then in whatever order the logical statements come out, to be able to say something, it has to say something anyway. Whereas if you're just using a proof by contradiction, and some constructivists have that as not a constructive approach, then you could say, well, I got backward. What you said was yes, and what's denied by it, and so now it just says either one, whichever one's last wins. And that's, this just kind of part of the idea of all the terms and just being objects, loose and free, that otherwise that would invalidate, say. If it can either only invalidate or not invalidate something for statistical and scientific hypotheses, that it invalidates not being a temporal relevance modal logic this way. So Quine is quite thorough, and then he helps address a lot of the different systems, and these systems have these different strengths, and then they're various levels where they can be applied quite largely to large bodies of work, many dots, many blanks, many combinations. Quine says, in connection with the modalities, yields something baffling, more so even than the modalities themselves. Videlice talk of a difference between necessary and contingent attributes of an object. Or that's just purely a matter of the tableau saying, oh, well, you've allowed material implication in. I'm sorry, but that is a hazard you've introduced. And so to leave that out is just got to write that out more fully. It's not you're not losing anything by losing material implication and making it so that false antecedents don't say anything, instead of like, oh, well, that's always false, the supposed clause, so it's a true thing because pigs have wings and I see day in hell, or something like that. Or it's a false consequence, like, oh, well, it's got a false consequence, it'll never be true, so whatever you say, I don't care, it's material implication. It just makes this one division rule, not P and Q. It's like, that's just sticking out as unfounded, and it's like, well, that's because it's just non-contradictory and it's a double negative. But all these thinkers have used it over time to leave it in. Is like, but then that makes it possible to write a slight and an aside up front, and then all this other stuff like doesn't have to be justified. But this is what it really needs, kind of, and it's kind of what Quine is addressing here is the baffling. So let's see what he has to say about that. Perhaps I can evoke the appropriate sense of bewilderment as follows. Mathematicians may conceivably be said to be necessarily rational and not necessarily two-legged, and cyclists necessarily two-legged and not necessarily rational. What if an individual who counts among his eccentricities, both in mathematics and cycling? Is this concrete individual necessarily rational, contingently two-legged, or vice versa? Just insofar as we're talking referentially to the object with no special bias to our background grouping. Mathematicians as against cyclists, or vice versa. There's no semblance of sense in rating some of his attributes as necessary and others as contingent. Some of his attributes count as important and others as unimportant. Yes, some as enduring and others as fleeting, yet but none as necessary or contingent. They're all contingent in one sense, and they're all necessary in the other sense. So yeah, I can see why that's baffling. If it's like, essentially, there's some things there's yes, no, and then don't care. Yes, no, maybe, don't know, don't care, and these kinds of things, which are not necessarily as like, the light is yellow or green or red, and it is with regards to its perceived implication of the traffic lights system, that's keeps people in a timely manner able to cooperate their driving direction decisions, after which it's water under the bridge. So these are the kinds of things that help show that when trying to talk about logic in the entire tableau of all the truth tables and all the values, all these truth values, semantics values, true, false, don't know, don't care, that these matters of connect the dots and fill in the blanks for language and all the combinations make for a way to help get above this stuff by having A, getting rid of contradiction for inverse contradiction, B, getting rid of material implication. It's just a particular, and I guess you could say analytical, but it's just an algorithmic thing, really. But it's never relevant. It's just something that is kind of lazy, is what it is, and it's conflated and confounded. And I've always been, ever since I was presented that 20 or 30 years ago, I was like, well, that's not true. And they're like, well, one of the greatest newspaper article writers of all time, who has the highest IQ of any person on the planet, says it's true. I was like, well, yeah, the last thing I read from that columnist was like Monty Hall and changes probabilities. That's not true either. So, 2 out of 2, it's pretty bad. So anyways, getting back to this then, Quine has got a lot going on here, and he's kind of hinting that he would like to have something that, because these baffling things basically stand out as paradoxes, and we can't have any paradoxes in a mathematical logic, except perhaps that there is one at all. Even the liar paradox, the last little thing that just can't be right in a language otherwise of truisms, just serves as an example of a structure that would be untrue. And then other ones can be related to it by connecting the dots, filling in the blanks, making all the combinations, and showing how that it can be reduced to that. True. Radical translation. Key idioms. False predilections, ontic commitment. So here I usually say ontological commitment. And then we have also ontic commitment. And then the deontic is something else to consider with regards to what idealism is. And then again, a lot of this stuff are the poor logicians all have to work themselves away from material implication, but half of them are using it as an escape hatch, and so it's like I don't really have too much to say about 20th century logic, but it's a thing, you know. I mean, I totally I get the or I like to think I get the direct implication, and all that's great, and relevance logic, and is perfect. And then all these different kinds of objects, and relating these different kinds of activities and different kinds of language about it. But then in some of the formal accounts and the foundations, there's big problems. The difference is not, they say, just a difference in two sorts of objects. One is space-time and one not. But the difference in two senses of there are. So that in the sense in which there are concrete objects, there are no abstract ones. But then there remain two difficulties, a little one and a big one. The little one is that the philosopher who would repudiate abstract objects seems to be left saying that there are such after all, in the sense of there are appropriate to them. The big one is that the distinction between there being one sense of there are for concrete objects and another for abstract ones, and there being just one sense of there are for both, makes no sense. Well, if you already have that, your theory has that any theory that any of us has is already incomplete. But there is one at all, this comenius language that all our Coleridge languages attain to, or your language or my language. Then we could say that it's like, well, we all have our abstract objects as our own models of contingent objects in our theory. And that includes all the concrete objects, which happen to always be true and right every time you sample them and find that they're so. And because this modal, meaning it's the mode, it's temporal, meaning it's up to date, and it's relevant, meaning it is the thing itself. So this is more of Quine having to suffer from kind of all the richness, you might put it, of some of the sophistry associated with this logic and this development. When you can see that what he's hoping for is something that would help get above that stuff and beyond, while being fully in it as well. So Quine at least helps to reflect on these things, and so that's perceived as gratifying. Excuse me. Futile cavilling over ontic implications gives way to an invitation to reformulate one's point in canonical notation. We cannot paraphrase our opponent's sentences into canonical notation for him and convict him of the consequences, for there's no synonymy. We must ask him what canonical sentences he's prepared to offer. So the ideas of universal language has that that's what a very strict nominalist is, for taking the strength. He's like, I don't have to tell you anything or assume anything or make any analogical commitment to these objects is all except C rule 1, and then when I add material implication, C rule end. And so when those don't agree, I can see how you can say they don't agree. Thus, if you demand that I make a formal statement that's going to be entirely logical, temporal, modal, and relevant, well, that would be something, wouldn't it? So, ontic implications of these kinds going. How the first, it's rehabilitate the quasi-modal and put that in its own place and give it its own name, where it is true about what its implications aren't. These are what they are. Attributes and propositions. Question about identity of attributes. Limit myths. The notion of the infinitesimal emerged from the question how to deal with rates, e.g. instantaneous velocities. What does it mean to say of a particle that in a momentary time t, its velocity is 10 feet a second? Or is it 1/10 seconds per foot? Not precisely that during some actual periods of a second, say hundreds of a second spanning t, the particle traverses the appropriate distance of 10 feet, tenth of a foot, for the velocity may change, Newton and Leibniz answered in their differential calculus by positing infinitesimals, quantities infinitely close to zero and yet absurdly enough distinct from each other. See, when we have a language and we're just connecting the dots, it's an infinite language. That's kind of what they're dealing with. Is like, well, we have like one word, but there's like all the words. It's an infinite language. So trying to say that is we only have anything to say is just an infinitesimal word, and at the same time that's like to connect the dots, and then the fill in the blanks is kind of like, well, you can just start with blanks, and then as you fill it in, there's only so many words that kind of fit. Okay, and those are sort of relations or whatever, and it's kind of it covers much more. And then there's like these infinitesimal iotas of these things, and then lastly, these combinations is could be all of it. There's more ideas of spaces of words and what spans them, the geometry of words. This is called word and object, but then it's also with regards to like word and is geometry, these kinds of things. So it's a super classical case, and we point to Zeno's arguments, and we say Zeno eventually has an example after Aristotle that arrives at Aristotle's continuum. It is beads on a string, contiguous values, iota values, infinitesimals, only exactly between 0 and 1, constant, monotone, strictly increasing. It's just a simple super classical exposition, and then one of these available means of describing an object, like the isoperimetric circle, that otherwise would not be given except by mathematics. And that the account of Zeno and the limit, this chapter is about the mathematical limit, and then the infinite limit, the continuum limit, that this would have to be kind of in the surrounds of what this is about. Give true and valuable results. Says conflict was resolved by Weierstrass. How the sentences of the differential calculus could be systematically reconstrued so as to draw only on proper numbers as values of the variables without impairing the ability of the calculus. So that's great, and that's analyticity in the usual sense of what calculus provides some perfect results. It's like the numbers that come out of it are like one full revolution, and not 0.999 or some granular bit to the left or right. It's round. And so then that's in all the epicycles of all the world, that when you look at, like, well, if the Earth is spinning around, and the Earth is spinning around the sun is kind of spinning around. The sun is kind of spinning around its arm or whatever it's orbiting, its orbits everywhere, all the way up to the galactic scale. And they're like, hey, do you notice by the time you add up all those angular moments, Earth's speed is approximately half light speed? Oh, really? Yeah, it's like, furthermore, it's like 1 year is like 1,000 times like 10 cubed. The path of one revolution of the Earth about the sun is like 10 cubed, the distance. That's a different thing, the numerical coincidence. But the light speed bit is kind of helping. It might help to explain. It's like, well, why is that a physical quantity, and is that so everywhere? It's like, well, yeah, if you define it that way. That, though, is sort of a higher superclassical account in physics somewhere about what is this finite constant that is light speed, what makes it running a constant. That then in this superclassical accounts, though, are the ideas that there are perfect ones, like the geometric series, that do give transcendental numbers, like pi. And so the same kind of goes for language. To solve these quandaries of language and logic and language, is that the promontories of mathematical universes objects arise there, and then that they are what should be considered as the mold of these things. Because for a plain nominalist, they say, well, I never mentioned all of mathematics in my theory. It's like, well, mathematics mentioned all your theory in its theory. So, and everyone that is the same model theory has a model as of about it. So then it's able to then in any internally consistent model of that is same, to show that the same things are so. And that's one of the great reasons why we have things like Gödel's incompleteness. Is like, well, at least our inductive half account models that purport to complete themselves, I got my completeness terms, also are incomplete if they got to be extraordinary, so somehow they have to be shown by an extraordinary account, of some superclassical account? Yeah, sure. Then that makes for so that, while at the same time it kind of makes randomness or fourth dimension less kind of, awe-inspiringly large. It does say that it's complete, and so that's kind of awe-inspiringly large. The appeal to ideal objects in mathematics occurs regularly through universal conditionals. So when you have universal quantifiers, then there's an important step called the quantifier disambiguation. So for each, for any, for every, for all, are considered unusual treatments that counts like this as one thing. For each, for any, for every, for all. Yet they're different words, and so you can usually write it, for all, for all, for all, for all, for all everywhere, if you're going to make a statement. But when you get into singular and plural, and with regards to the sortes or the heap paradox, and seeing out of it, and then having other reasons why the quantifier disambiguation is to occur, as for things like Solomon Pfefferman and quantifier ambiguity, that he presents that this general universal mathematical object that Quine has just mentioned, universal conditional, is more than one. And so the existential and the universal is sort of the study of the singulars and particulars and the universals and absolutes in Quine's account is looking behind. And then at least though we have kind of something to point to say, well, they're getting into that with like impredicativity and Weaver and Pfefferman and quantifier ambiguity, that for each, for any, for every, for all are sometimes same and sometimes different, and it matters. So they're ideal objects in mechanics. The non-existence of ideal objects consequently does not falsify mechanics. It leaves such sentences vacuously true for lack of counter instances. So that's the anomalous approach, is like, I am safe in my bubble. It's like, well, I got a bubble over here that works just like your bubble over there, and in fact, it does, and it's got this other stuff about it, including that's connected to this other bubble. So it must be. Thus, mechanics may seem better off with respect to ideal objects than the differential calculus had once been with respect to infinitesimals, which are still there, but the contrast is superficial. Well, yes and no. The contrast is kind of superficial, because then we're looking at a difference between like a connect the dots thing and a fill in the blanks thing. What should worry us about the ideal objects is the following. If by physical laws there are no such objects, and hence by physical laws all universal conditionals concerning them are trivially true, then how is it that some of these conditionals rather than others still evidently impart useful scientific theory? Well, he starts with there are none, and then that they're trivially true, which is like this fallacy of material implication. So we don't really have to worry about that. And it really does speak to this, like, let's get material implication just out of logic. It's just a useful algorithmic thing, sometimes called quasi-modal logic, that makes the explosion of all the possibilities easier to kind of chop through. But it's not very resistant to meddling, and it's here it's called the weak logicist positivism's account, and then we need a stronger logicist positive accounts that finds that it always reintroduces itself, the relevance logic, a modal logic, a temporal logic. And we can point to Plotinus, or not Plotinus, Chrysippus's moods. And then as with regard to the Neoplatonists, that's where this kind of school comes from, like from Plotinus, and otherwise about whoever came up with material implication and called it analytical, when it's just like coloring beyond the edges or whatever, and it's coloring outside the lines, and saying it doesn't matter because we're only looking inside the lines. So I've over the years and years definitely been always firmly of a position that you don't need material implication for anything logical. And truly, direct implication provides anything that any kind of common sense logic can come up with. But that material implication is it will be seen as just a bad idea. It's called quasi-modal. It's not modal, it's quasi-modal. under some contingencies that may or may not be so. And when things change in the temporal, indefinitely, anytime, then it will have been falsified. So it's not logic anymore. This quandary over ideal objects has its solution in the theory of limits. And so as it does, then these limits of the completions. So the limits are what it's arrived at. And, I mean, it's not like the limit, it's like, well, this is the upper bound, though it kind of is. The limit is like in the infinitary, it will both reach this and not surpass this, that it reaches the line. And so to say that so in language for these ideas of connect the dots and fill in the blanks and all the combinations for geometric settings for languages or words. And as with regards to calling those algebras or what, that we have geometry and number theory and algebra and analysis and arithmetic and topology and function theory. Then for the spaces of the words, then connecting those to objects as geometrical has that for a Platonist idealist Renaissance, 21st century Renaissance position of the ideals with regards to this very strict and thorough nominalist account, so self-justified as we consider from from Derrida and Husserl on why, besides being very strong nominalists, logicists, positivists, that is kind of weak the endeavor, and they've just been having to deal with what they could deal with. And the deconstructive accounts at least give otherwise way to provide critical resource, critical discourse about the things. Both are required in the overall discourse. That it's a stronger logicist positivism this way. And none need material implication except as an exercise and demonstration of its pitfalls, vagaries, impredigativities, and ambiguities. The appeal to ideal objects in mathematics. The doctrine of ideal objects in physics is symbolic, in quotes, as this word is used by literary critics, psychoanalysts, and philosophers of religion. It is a deliberate myth useful for the vividness, beauty, substantial correctness with which it portrays certain aspects of nature, even while in a literal reading of falsifies nature in other respects. It is useful also for the simplicity that brings us certain computations. Now, simplicity in a theory that squares with observation sentences so far as its contacts with them go is the best evidence of truth we can ask. No, it's not. It's a great thing. After Occam, the discussion of Occam, and the nominalist position, and the idea that simplicity is has got the least baggage, and so it's superior, as Kleene is kind of putting it here. As that it's also right that these ideal objects reimpose themselves, and so doing without that ends up not being simple as it seems, and having kind of the false floor, as it's put, and it's not just after cutting out around the lines what is able to, that fills the space of these words. So simplicity is not necessarily what's considered the best thing. As in fundamental aspects and elements, there's like Schaffer's laser after Occam's razor, do not go multiplying fundamental objects unnecessarily. Here there's that, well, some of these fundamental objects are the only way for us to multiply these objects. You can take a naive comprehension and you're welcome to a whole slate of material implications, paradoxes, and other problems of ordinary, not extraordinary, naive comprehension. So we don't, but we have to provide something to make for these things from the beginning. If it's to be not too simple, yet it's simple, the extraordinary from the outset of these things. When we paraphrase our talk of ideal objects in the Weierstrassian spirit as sketched above, so Weierstrassi's just got delta epsilonics, and it's great, and it's quite old-fashioned. It was probably in style for quite a long time. And it just gives us like, well, inductively, the limit is not less, and it's not more. So it's equal. And then we don't say it's equal, we just say it's the limit exists. But then in the next derivation or algebraic manipulation, it's discarded that fact and it said it exists. So we all know from these discussions here that numerical methods are approximations that have a normally non-zero error term. And so in the limit, after billions and billions of steps, they approach the true value of these things. And then their great facility is like, well, we just compute 3 steps and that's close enough to be, close. So the ideal objects then having like you mean the ideal objects of mathematics? It's like, well, yeah, it's like they're transcendental, and then we got convergence and emergence. So they live in the mathematical universe. These are the ways of the things. It is once more relevant to remind ourselves that paraphrase makes no synonymy claim. Well, synonymy of the metaphor fails eventually, but there is a metonymy of the name of about all the names, which does not fail. So there's at least one ideal where that is not so. So Quine has absorbed so thoroughly all these great accounts of how he can be a sure analyst in this tradition of this what was a modern and future seeming analytical tradition after all this, the nominalists and Occam and back to Plotinus and these Neoplatonists, not Platonists, Neoplatonists. That these go to show that that's now the lens and the language of Quine has this as his where he's firmly established that what he's saying is so, and then these other things that at least it's graciously received. That Quine says, "Oh, by the by, this is hanging over our head, and nobody is quite sure except that it's there, but we ignore it." It's kind of Quine's approach here. It's like that is beneath our feet. Then it's easier to deal with this way. The continuing utility of the mechanics of ideal objects and of Newtonian mechanics. And the same was true of the infinitesimal calculus. That said, let the reconciliations proceed. Each such step advances our understanding of the world. So he's talking about geometrical objects. And then a dualistic theory of spatio-temporal reality, where two sorts of objects, physical and geometrical, interpenetrate without conflict. Or there one thing is the idea of a mathematical universe hypothesis. Why couldn't we have them together? Quine asks. Is it just that these two categories would be intuitively too much alike to make the separation of laws seem natural? He talks about the differences between like points and bodies and mathematics concerns. And space and time, the ideals. And here that we have, like, of course, our whole axiomless geometry and all this stuff. If motion is relative, then obviously the question whether a given spatio-temporal region or aggregate of point instance is constant in shape through time, or whether its internal distances readjust through time, will depend on the relative movement of the point of view. So this helps explore like geometry as motion, as perspective and projection. And so the question whether the shape at a time is spherical or elongated. That's kind of like the spiral space-filling curve, and whether it's just a line, and the hypercube distance is 1, and these kinds of things. But this is to say only that shape at a time is relative to frames of reference. The geometrical objects whose frames are concerned remain absolute aggregates of point instance, however shaped and however specified. So here we have this ideas of there's space. It's like, well, space-time is like a whole space, I think. And then there's frames. It's like, well, what's a frame? It's like, well, it's an area of space. Whatever's in it that's its frame. Any area of space, any object in space, it's in a frame. It's in all its concentric frames. It's frames are frames. It's frames are frames. And this kind of that. All in one space, see. because the contents are defined in the frames, but the outside sort of spaces in defines the distance. So you got kind of the metric and norm, and they're two different things, but they're meant to be the same thing, that length and distance. So the idea is that space frames and frame spaces nest in each other, so that any frame is also a space, and any space is also a frame. So the way this works then is like kind of leaning back to this idea about the integral and differential accounts together at the beginning, is then as these instantaneous activities always get constantly evaluated instantaneously through all and each and every instant of constant monotone strictly increasing time, then it still results this same continuous process everywhere. Space frames and space frames, or Rama Raman and Rama Raman, or space frames and frame spaces, or frame spaces and space frames. May we then hold to the naive view, Quine asks. Here we have a dualistic theory of spatial temporal reality whose two sorts of objects, physical and geometrical. There's no conflict, simply because the physical laws are not extended to the geometrical objects. Well, see, the more they make sense, and the most simple they can be is that they do. So, if Derrida and Husserl are kind of like saying, it's like, well, geometry is definitely in logic, then Quine is kind of saying, well, either physical objects are definitely in logic, or they don't conflict. Are we prepared to admit absolute positions and therewith an absolute distinction between rest and motion? Frame spaces and frame spaces and space frames and space frames. Start making combinations. We can accommodate this relativistic scruple simply by adding a dimension and speaking in positions not in space but in space-time. Sometimes you can't just add a dimension. You can add a dimension. It's a perfect thing to do. It's the absolute idea of making an idea about something and keeping it on the side and bookkeeping it in whatever numerical resources it takes to do that. But physics and geometry in the universe doesn't just simply add a dimension to handle all the dynamics of things. It's like the dimensions that it has. And so this gets into all this like dimensional, dimensionless, alternators, resonators, and these ideas that they keep for the hologram of space-time, which is like three space dimensions and array of time. And space goes on forever and time goes back forever and that kind of thing. That here, Quine's saying, well, we can keep it real by adding another dimension. And in that way, at least we wouldn't just be lost. We can conscientiously say we've made a mark to go along with it. But then in the numerical resources, when that runs out, and it's like, I can't keep up on the related rates. It's more than what I could keep up when this dimension I'm building, keeping maintaining, to these ones that nature automatically does in 3 dimensions of space and an array of time. Logically, of course, it's contingent and it's outside that. So that's the thing. So Derrida and Husserl in their proto-geometry and this kind of stuff. Here is that Quine's proto-physics is, he considers it yet entirely being that mathematics is ubiquitously successful to describe physics. Even if it's way higher order than what we could figure it would be about, it is still kind of successful. And he would add dimensions to do so. Whether it was better to stay within the 3 spatial dimensions for our geometrical objects or better to look beyond space into space-time for them. So here the problem is that space-time was like, well, we added another dimension, this other half array of time. It's like, well, use that for everything. It's kind of like, well, how's that going to work? It's like, well, when they did all this sky survey and we're finding red shift and blue shift, when they had blue shift, they just kind of, they just hid that in part of a range of numbers behind the dot or something like that. It's like, what do you mean they overloaded that for everything? It's like, well, there was nothing else to overload. So space-time is the one that's like a free dimension. Then when it's time, it's like, that's your own responsibility, see? And you can't just go making a theory and say, oh, I've just made a free dimension attached to all these considerations to it. Say, well, what's in it? It's like, well, let's start with like maybe a one branch of complex analysis. And we'll start with that, We could be able to call it analytic and use mathematics for all this other stuff about it. It's like, well, that's great, but you didn't tell me that anybody else could use it for any such other matters of things. It's like, well, you want to leave some room in that because there's more dynamics going on in it. There's like 3 kinds of electrostatics, electrodynamics, and light speed c, which might be a constant defined by local conditions. It appears to be so. Whether it is better to keep it simple or to make it overly general, and that over generalizations are generally unsound. Let fashion and terminology not mislead us into viewing geometry too differently from physics. So he's expressing a given confidence that they should be the same. Though the one's justification is like, well, we're keeping it simple for this enterprise by making it complex for this other enterprise. That you see the whole simplicity principle, simpliciter and all that. It's good, but it's not simple. Physical theorizing, Einstein and Euclid, and these kinds of things, many of which have been discussed here and for many particular situations. Well, gentle readers, I shall hope you had a great day today. It's a sunny day. A clear day, I suppose you'd say. Warm regards.